So what are we going to be talking about today, Dr. Carrico?
Well, today we're going to talk about a couple things. We'll start off by discussing Hooke's Law. Now, I'm not talking about this hook. I'm not talking about this hook. I'm talking about
John Cena!
Alright, I'm just kidding. But now back to what we were talking about. So, what really is Hooke's Law?
Well, according to this, Hooke's Law states that both the force of the wire pulling upward is proportional to its displacement downward, and that the restorative force acts in the opposite direction of the displacement.
Well, that was a really good definition. Wasn't it, audience?
This diagram shows how Hooke's Law works. Not only does it show the tensile force, which is the springs giving way and sagging with the weight attached to them, but if you were to take off the weight attached to them, the springs would snap back into place because of the restorative force. Dude, what are you doing?
Sorry, I was on break. I was on break.
Alright, now that we're back from our short break, let's get on with this. So we have cohesion. Cohesion plays a large role in this law because cohesion is the attractive force between particles of the same kind. And in solids, it's much stronger and greater than it is in gases and liquids. This is because the particles in a solid have less energy to move around. Because of this strong attraction, the solid will tend to hold its shape. Now that we've talked about cohesion, let's talk about tensile force.
Tensile force is the compressibility or stretching of a load. The way this works is if you have a steel wire suspended vertically and you have weights hooked to the bottom of the wire, it will stretch very, very slightly, and the stretch will be directly proportional to the tensile force.
Psych!
Now that we know about tensile force, let's talk about restorative force.
Okay, restorative force is the force acting against tensile force. This basically prevents the wire from stretching any further. Restorative force also doesn't govern the stretch of wire, but it governs the stretch of all solids.
So in the last frame, I think our green screen finally broke. It looked like it was dark outside. Now it's a kitchen, and we can't fix it. So we're just going to continue on with the rest of the video. So
Our next big topic is tensile stress and all the things that go with it.
To understand this, we need to know what stress is. So, stress is the deformative tensile force per unit cross-sectional area. Basically, it's the force that causes the solid to change its shape past its original form. Also, strain is the relative amount of deformation, or the ratio of the object's change to its original form.
Now, tensile stress or tension is tensile force applied to the cross-sectional area of a stressed object. To explain this, think that the length of a material tends to increase in the direction of the force, while the volume of the material stays constant.
To tie in Young's modulus in with this, it's the amount of tensile force required per unit area to produce a doubling in length. In layman's terms, the amount of force it takes to stretch the object to become 2 times its normal length. But this usually doesn't happen because that's too much stress and will cause it to break.
Now, tensile stress or tension is tensile force applied to the cross-sectional area of a stress object. Now, tensile stress or tension is tensile force applied to the cross-sectional area of a stress object. To explain this, think that the length of a material tends to increase and the
That was a good